Good morning, students. Today we can learn the concept of open ball in a metric space. It's very essential to learn all the ideas behind the concept of metric space. Okay. If you take any definition, the open ball at x with the radius r will comes into play. So it is start with it is basic to start with the definition of open ball in a metric space. So let us start. You take a non-empty set together with a metric D, that is a metric space, and you take a point, arbitrary point x in the set x. Okay. And for r positive number, given r positive number, we define the following set. Set of points y in x such that distance between y and x less than r. Okay. As an open ball, center at x with radius r. I will explain what is it. So, to define an open ball, you must give a point, okay, x and a positive number, and consider these points. Those points in the set x, okay, collect all possible points in x whose distance from x is less than r. Okay, you denote that set by b of x comma r, and say it is an open ball center at x with radius r. That means we are collecting all possible points y such that y and x distance is less than r. Otherwise, you won't consider those points. Okay, that is, you collect all possible points in the set x, in the metric space x, whose distance from x is less than r. Okay, and denote that set by this letter b of x comma r. That is a ball, open ball with center x and radius r. Okay. So this definition is very important in learning the total concept of a metric space. Okay. Let us give one example of this open ball. Okay. You know very well that the set R, okay, together with the metric d of x comma y defined by mod x minus y, okay, okay, is a metric space. So in this metric space, you can take any point. For example, if you take A is any point in R, and you can take R positive as a given number, and we can get what is this open ball with center A and radius R positive with regard to this metric. Okay. So what is the definition? So we collect all possible real numbers. Which are having distance from A less than R. Okay, that is b of y comma A is less than R. So we can rewrite this set, okay, because we know the metric exactly as mod x minus y. So we need those points in R. When I say those points in R, that means those points in a metric space R such that mod y minus A is less than R. That is, you collect all possible points in R such that this mod y minus A less than R means that y minus A lies in between minus R and plus R. Okay. We know that mod x less than maybe if you say delta, then x satisfies this property. X lies between minus delta to plus delta. So we need this set b of a comma r. For that we are writing what is it actually by definition. What is it mean? Those points y in r such that d of y comma a less than r, and we rewrite the statement because d is, we know that mod y minus a, and mod y minus a less than r means that y minus a lies between minus r to plus r. And what is it actually? Okay, set of points y and r such that y you add minus you add a through this inequality, you are getting a minus r plus y plus a plus r. So y should be a real number with this property, that is y lies between a minus r to a plus r, that is it is an open interval a minus r comma a plus r. What it actually is, you take a set of real numbers in the real line. Okay. In that real line, you are having the point A, and if you give r positive, then a minus r is a point here, then a plus r point here, and all these points between a minus r to a plus r, okay, it will come as an open ball. Okay. So it is clear that in R, the usual method, you can give any point and any radius r. Beyond a comma r is an interval around r, okay, that is symmetric interval around r of length 2r, that is namely a minus r to a plus r. So this is the definition of open ball in a metric space and an example. Okay. With the help of this open ball definition, we are going to define in the next video. We are going to define what do you mean by an interior point, what do you mean by an interior of a set, and what is an open ball and open set. Okay, with regard to this open ball. Okay, in the next video we can go one by one. We can learn that concept. Okay, thank you.